Hello everyone, welcome to helpyourmath.com. So this time we will talk about graph-the rational function. Okay, so please look at this decimal file. Just want to introduce basic rational function first. So I made a y of 1 over x, 1 over x squared, and then just a little bit different one, 1 over x squared minus 1, and then last x over x squared minus 1. So that's those four functions I want to introduce first because those are basically basic format. Okay, so now this one. So that's the 1 over x graph here. Okay, so as you see, whenever this x is negative value and then getting bigger, then this value going toward that basically zero area. For example, 1 over maybe negative 100, 1 over negative 1000. It's almost zero here, right? Because it becomes 0.0001, negative 0.000001 like that. So whenever you go to the left hand side, you see x value bigger and bigger. It is close to 0 though. But as you see, it never across that x-axis value. Okay? And now the right side here, so whenever x is bigger and bigger, it also go to where? Go to almost zero. So you see the y-coordinate value getting bigger and bigger, right? But it never across the x-axis, right? Okay, like that. And now, on the other hand, if x value is close to 0, like a 0.5 and 0.01 and 0.001 like that, so look at this. So whenever x is close to 0 or more, the y value dramatically, in this case, decreased here. So when x equals negative 1.29, it becomes negative 0.775. But now, negative 0.48 becomes negative 2.128, and negative maybe 35, negative 2.874, and then keep going. Then now, whenever the x value close to 0 or more, x value, y value dramatically drop down, right? Okay, same thing here. So whenever x close to the 0 here, the y value increase dramatically too. Okay, yeah, like this. They're all behavior of this rational function. Okay. And then why this is happening? Because this function case x cannot be 0. You know that, right? If x equals to 0, then this function become undefined. So therefore, based on x equals 0, based x equals 0, this line, it keep going up, but it never approach the y-axis as well. You see? Okay, if I put here, then you see much better here, like that. Okay, I will keep going. So the y value increase more and more. And then, yeah, now I can zoom in here more. So you see the gap. Do you see that? Okay. Maybe a little bit more like this. Okay. Like that. Okay. So looks like it is kind of equal to 0, but if I zoom in, then you see still gap here, which means this line never across the y-axis as well. Make sense to you? Okay. So therefore, x equals 0 is basically this graph's the vertical asymptote, because it never occurs that. At the same time, this 1, which means x to the 0 power, now x, which means x to the 1 power, the denominator power is bigger than the numerator power, so y equals 0. This is the horizontal asymptote basically. Make sense to you? Okay. And now, what about this function case? As you see, it shares exactly same vertical asymptote x equals 0 as well. But unlike this graph here, the second blue graph case, both are above the x-axis. The reason is because of this one here. Even though you put negative value, this value become always positive. Negative square become positive. Positive square, of course, it is positive. That's the reason this graph is always above the x-axis. Okay. Then now, what about if I make a cubic here? Can you guess what's gonna happen? I'm gonna make maybe y equal to 1 over x to the cubic. Okay. This behavior looks like 1 over x here, right? Of course, the graphic can be sharper or a little bit blunt, but behavior is exactly same here. So this purple graph also looks like 1 over the x graph as well. Then which means whichever x to 1 over x to the r power is always have the same behavior like y equal to 1 over x. That's the key point. Then what about I switch this is a fourth power? Can you guess it? Yes, I agree with you. See? After we switch 1 over fourth power here, it looks like 1 over x squared power as well, which means whichever 1 over x to the even power, this behavior very similar to 1 over x squared graph. That's why this 1 over x graph, 1 over x squared graph, they are basic functions. Okay. Another basic function is basically 1 over x squared minus 1. This one, you may think, it looks like maybe this one, but it is not true. The reason is we have two different restricted value, which is 1 and negative 1. Okay, so look at this, please. As you see, this time we have three different regions here, 1 and 2 and 3 different regions. So if you solve for denominator here, then you will get x equal to 1, x equal to negative 1. Those two will be this one's vertical asymptote. Okay? Like this. Okay? So that also please remember that because this is the one of the basic format graph. Okay, then what if we have maybe the variable on numerator? Yeah, it is possible too, right? Okay, so I make one more here. So when I click this one, so you see, it's pretty different from what we just discussed here. The first one, we have two tail side, both are increasing. The center part is kind of a round shape, parabola shape here. But now, this one case, we have, looks like 1 over x graph shape, but we have middle of them here. Okay? But it is because it also apply based on the numerator x here. Make sense to you? This is the odd degree variable. This is the even degree variable. That's what happened. Okay? Then what if I switch this is the x square maybe? Okay, let's see. So now it looks like this one's behavior here, right? Because everything now is even. But now what if I switch to cubic here? Yeah, it may follow, looks like 1 over x, but we have middle section here. So, see? Okay, then now, as you see, this one looks a little bit different because now the cubic is bigger than square part. And then that's we just call slant asymptote. Okay? But now I just go back to original. Yeah. Okay. So today, we basically talk about basic function of the rational functions graph. Okay, so based on that, so next video, we actually design the graph of each given function. All right. So thanks for joining today, and then I will see you in the next video. Bye.